Jenny.
What?
I'm going to introduce us first.
Oh, you
Me.
said sing!
Bass. Jenny Marsh in the house.
Woo!
Miss Reese in the house.
Woo!
And Jenny is excited to sing this song with me. And I'm excited to sing the song with Jenny. Jenny, are you ready?
Yeah.
Alright, 1, 2, 3. Got to give the people give the people
What they want.
Woo!
Yeah.
It's challenge week. Things are crazy.
Very crazy.
We have the lovely Jenny Marsh. We have more people.
Oh, this is my singer.
So exciting. Do you want to be on this homework video?
No. No.
God.
Oh. Oh. No.
There we go.
Oh,
Yeah. We love algebra 1.
Wait, is it actually done?
Yeah.
Yeah. Hey, come on, come on. We're gonna. Hey.
I'm cute.
done.
Guys,
All
say
right.
how much you love homework videos.
Not at all.
Well.
I love you guys too.
Follow me on Instagram.
All right.
Hey.
So that was a very entertaining
What?
start for
What's
everybody.
What's wrong?
No way we can keep this.
No.
No. Mr. Bass.
Jenny's intro. Okay. So depending on how long that took, we might cut it out, but we might not. All right. So today.
My intro is going to be in there.
Oh yeah, of course it is.
Something.
Okay, we're still under 2 minutes. We got this. All right, so today we are going to be making some big connections between the undoing method and our old school algebraic method. So our goal is to be able to identify where these are saying the same math action, because they do say the same thing, they just look pretty different. Could you please take the first minute and write down everything you see on the board? Good job. Okay, so starting with our example, guys, -4 times x plus 1 equals 9. So, guys, to begin, can you please, I'm trying not to stand in the way, fill out your undoing map here. Now, in order for us to undo, we have to go forwards first. So I'm going to go ahead and do a couple of those with you guys, and then I'm sure a question or two will pop up along the way. So, guys, please remember that our order of operations, which I like to call GEMDOS. I know, Jenny, it's funny. Jenny, what letter do we usually have instead of G?
Grouping.
Yeah, so grouping is our G, which is parentheses and brackets. So I tried to use not P, but G. So that might be a little bit weird, but we're okay. So guys, let's do our scan of our order of operations. Do we have any grouping? No. Do we have any exponents? No. Do we have any multiplication? Ding, ding, ding. Yes. Jenny Marsh agrees, so we have to be sure about that.
Yeah.
-4 times x is going to be our first operation. So it's going to go on our first forwards arrow. -4 times x looks like -4x. Can you guys please take the next minute or two and fill out both this forward arrow and our final result for our equal sign? There we go, you've done it. So above this arrow should be +1, and then that will build all of the side of the equation, -4x +1. Here's where we're going to use all of our great thinking that we did moving forward in reverse. This is what we call the undoing part. We work backwards from what we are trying to equal, which is 9. I love the undoing method, guys. It's a very visual one for me. So our top arrow forward is +1, so our bottom arrow backwards must be -1. Instead of times -4, we're going to divide by -4. Sorry, that's a little small, guys. Because we're dividing by a negative number, I always make sure parentheses are after it. So let's go ahead and run the race of our undoing method. Guys, 9 minus 1 would be 8. And then 8 divided by a -4 would be -2. And remember, that's where our final answer is, which we will check out, before we're done, because that's always part of our process. So guys, our goal here is to be able to connect, not especially, but entirely all of this backwards thinking to our traditional way of solving. So in order for me to get started with that, I would like for you guys to write down algebraic, the same equation, and then our reverse order of operations, which is a little sad Meg, right? So it's literally just the opposite order of geminus. Don't get freaked out. We're going to use this as a way for us to check what we do first in terms of deleting or undoing existing operations. So go ahead and just work with me through this. Write this down in your notes and make sure that you're scanning with me. So here's what I mean. The S in SADMEG stands for subtraction. So I want you guys to check if there are any subtractions for us to erase. Scan, 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 scan. This is a negative, but this -4 is attached with multiplication. We have addition next, so I'm going to say that no, we don't have any subtraction to undo. Moving on. We do have addition to undo, so that's going to be the very first thing that we erase. What will erase addition? Addition is subtraction. So 1 minus 1 is 0. Let's go ahead and stop and make a connection between what we just did and our undoing method. Guys, where do you see -1 in our undoing operation? Remember, this is down here. It's right here. It's our first backwards arrow. Okay, and notice that it's our first undoing step algebraically as well. After we subtract 1, because 1 minus 1 is 0, so I can not write 0 because it means nothing. Guys, what did you notice is going to be next on our checklist of things to delete? So we've taken care of subtraction, addition. Do we have any division to undo? I don't see any division here, so let's go ahead and cross that off. Do you guys agree that we do have multiplication to undo? -4 times x. So it's going to be next on our list. We use our inverse operations to delete existing ones. So -4 divided by -4 is 1. Maybe a lot of you have seen or remember to cross off those things that you're seeing here. And make sure that we use our properties of equality and always balance both sides. So divide by -4, divide by -4. Guys, our final answer is x equals -2. So before we prove that this is our final answer, I want us to make a couple more connections here. Just like we did with -1 and -1. Can you guys please go and identify where you see divide by -4 in the undoing map? Notice, guys, that our -1 was our first backwards arrow, and then our divide by -4 is our second backwards arrow, which is why we did it second over here as well. So, you guys are going to get sick of Mr. Bass and I saying this eventually, but we always want you to check your answers. So where we're going to end this video today is for you to take our final answer, which I think you know what it is, and go ahead and check this with the original equation. You should know what this means by now, and so we look forward to seeing it in your notebooks. Jenny Marsh, sail us out of here.
What?
Bye. See you.